Hello everyone, today I'm going to talk about triple integrals and density. Say you're given a value for the density to be rho equals 10, a constant value. And you have to somehow find the mass of the solid that you're given. So say we want to first understand what this even means. So we have some arbitrary solid in the x, y, and z plane. We're going to imagine that we are taking many small and tiny little squares to fill up this region. And I know my picture doesn't really show it, but this shape here is coming out in like a 3D way. So imagine that all of these tiny little squares that are infinitely small are filling up this region as much as they can. And this is the same concept as first level calculus that we learned, right? It's when you take the integral of a function, it's going to be the area under the curve, and you're breaking it up into a whole bunch of infinitely small rectangles. And in this case, it's the same idea, except it's going to be little cubes that are infinitely small. So to keep this in mind, let's take one of these cubes and draw it out to the side here. So on this side, this is going to be the difference in the y value, x, and z. So how would you find the volume of this cube? Just one of these cubes. You would do the length times the width times the height. And this is equal to the volume, right? Makes sense. So if you think back to what the density function is, it tells you that d is equal to, let's get a better thing there, mass over volume, right? So if this is the volume right here, then you know that if you multiply your density function times the volume, you're going to get the mass. And that's what you have been asked to. You want to find the value of the mass of this solid. So when you take the triple integral, you're going to have your density function, which I put as rho, and it has to be constant or else this way is not going to work. So you're going to have rho times dv. And we know what rho is and we know what dv is, so we can start plugging things in. We can find our bounds in a second, but it's going to be integral times 10 times dx dy dz. And say we're actually given a solid that looks something like this. Imagine a rectangle of some sorts, and say that the x value is bounded by x equals 2 and bounded by z equals 5 and y equals 3. So looking at this now, we can start setting up the bounds for our integral so we can solve it. So you have to remember that for a triple integral, you can just imagine it as separate integrals, but this corresponds with dx. This one corresponds to dy and dz. So with that in mind, we know that dx goes from the origin to 2. So it's going to be 0 to 2. And then on y, it goes from 0 to 3. And finally, on z, 0 to 5. So there you go. Now we're all set up to set up our integral to find the mass. So this is a pretty simple and straightforward problem. So what we would do is first 0 to 5, 0 to 3, and the integral of 10 is 10x, and that's going to be evaluated at from 0 to 2, dy, dz, and don't forget to always put these values, these outer parts here, because then it's easy to forget that you have those. So it goes 0 to 5, 0 to 3, this is going to be 20 minus 0, dy, dz. And I'm going to go a little bit faster here. Zero, which is 300. And if you're wondering what your units are for this answer, all you would have to do is look at the units of your density. So say we were given 10, and say it was given in grams per centimeters cubed. So we multiplied by the volume, which would be also centimeters cubed, and this would therefore mean that your units are going to be in grams. So this would be grams. And that's it.